All right, so yeah, as she said, we're going to be talking a little bit about some detection engineering topics today. But just real quick, background about me. My name's Paul Ihme, as Kendra said. I'm a co-founder at Soteria. I started off my career in the Air Force as a software engineer, and then moved over into the cybersecurity side of the house later on in my career. Spent some time at the National Security Agency, doing some of the offensive mission there. Spent some time at J.P. Morgan and in the Internal Revenue Service in the U.S. Doing hunt missions and security operations work. And then a long time ago, I used to work in fast food and did some landscaping. So if this whole cyber thing doesn't work out, I've got to fall back there. But there's over my career, I've had really great opportunities to work on what I've put here: offense, defense, and special teams. I've done some GRC work as well. And I think that's been really beneficial to me to kind of help me think about how how to go out and find bad things happening in corporate environments. So I want to talk a little bit, and I can't really go fully into the history here and really do it any justice, but just talk a little bit about the history of how we detect bad things happening in our corporate environments these days. So it really started out with antivirus and firewalls and things like that. So somebody like John McAfee would write a piece of software that would scan the files on your computer, and there were a handful of known viruses back then. It would look for characteristics of those files, maybe some strings or byte patterns that were unique to that file, and it would flag up and say this is a virus. And over time, as malware became more prevalent and threat actors started doing stranger and more sophisticated things, that just wasn't viable anymore. So there's been a very slow evolution, and again, this is a big jump, but really what's come to be the sort of state of the art and the state of the industry now is that organizations need to collect telemetry from various systems and help identify strange patterns within that for themselves. And you can buy products to do this. You can buy an EDR product to collect a bunch of endpoint telemetry, and it will come with a bunch of rules, and it'll say that it'll stop a bunch of threats. But there's limitations to that, and such that they can't really write great rules that are going to be specific to your organization, because if they write some rules for everything that's in the MITRE attack framework, they're going to throw so many false positives that nobody's going to look at it, right? Nobody's going to pay attention to the 2,000 alerts they get every hour, and they're just going to turn it off. And same thing for network security monitoring for SIMs. So really, what organizations need to do is they need to have this base capability where they can collect this telemetry, understand what's normal for their organization and what's not normal, and understand how they can write rules to find bad things happening. And that's really what detection engineering is to me. This is still a very immature practice within the cybersecurity ecosystem. I think this is something that is still kind of poorly defined compared to some other areas of expertise within cybersecurity. But the way I look at it is outlined here. So a detection engineer, first you have to make sure that you understand what you're looking for. So you have some sort of threat intelligence capability, whether that threat intelligence is a very organized threat intelligence team that spends all their time doing this, or whether your threat intelligence is scrolling through Twitter and reading through bleeping computer every day and just trying to understand what folks are doing. And there's different levels of maturity, but you need to have some input to help you understand what it is that you want to catch, right? And then you need to make sure that you design systems that can capture the telemetry you need. You got to get that data, right? You got to have something to look at in order to find the bad things happening, and have some way to parse that data and write rules against it. And then the focus of today's session is really going to be on these last 4 bullets on this slide. So once you have all this data coming in, you've got to be able to write your own logic to find bad things happening, for whatever definition of bad that you might have within your environment. You have to be able to test and verify that you're actually catching the things that you think you're doing, right? You can say that I've got a rule to catch this thing, but how do you really know? Maintain these things, because threats evolve, systems evolve. When you upgrade from Windows 10 to Windows 11, there's some changes to how the operating system sends that telemetry to you. So you have to make sure you're accounting for those types of things. And then I think it's also important, you have to know when you have to say, okay, it's time to retire this, because we're not really getting the value out of this capability that is required for us to continue maintaining it. So that's at a very high level how I think about detection engineering. There's people who might look at it differently or have different definitions, but I think that's a good sort of baseline that everybody can agree on. So within that, there's a lot of people who, and I'm sure that anybody who's ever worked in a SOC has experienced some of these things. There's a lot of pitfalls that can happen when you start writing your own detection capabilities. And I've just put down a couple of things here that we see folks struggling with, right? So first and foremost, if somebody comes to your SOC, right? Maybe you've got a CIO or a CISO or a CEO or a director or somebody in your leadership comes into your security operations team and they say, "Hey, I just read about this thing on the news. Can we detect that?" Can you answer that like with confidence, right? Can you say, "Well, I hope so because these tools should be maintaining those rules, and I would hope that they would do it." Or can you confidently answer that question and say, "Yes, we have this rule, that rule, this capability to look for this threat, and we have it documented. We know it's there." Or conversely, if you realize that you don't have that capability, do you know how long you've been unable? Have you never had that capability, or has that threat evolved in some way and you can go back and track like, oh, we had it and then last week something broke and now we need to go back and fix it, and we know that we have a gap of 1 week where something bad could have happened and we wouldn't have seen it. So really, it comes down to a handful of things. You have ineffective rules. People will write rules because they think that they work, but they have no way of testing them. Or what I've seen a lot in my career is somebody comes up with this great idea, they write a new rule, and now you're getting 10,000 alerts because you accidentally wrote a rule that sends an alert every time a new file is written on the disk, or every time a new process is kicked off. And then on the other side, sometimes you have this brilliant detection engineer who's writing this great next level detection logic, and then they go home for the day and your overnight analyst gets an alert on their screen and they have no idea what it is, right? So this is another problem in this practice, is that there's not a lot of great documentation and a lot of folks don't really go through the rigorous process to make sure that the knowledge isn't just living in their head of what to do when this bad thing happens. And then finally, I've seen this a lot when looking at security operations centers where somebody goes in to make an update and they realize that they broke the rule, but they have no idea on how to go back to the previous state, right? Like, I thought I just changed this thing, but now if I try to undo that, it doesn't work the way it used to, and I don't know what I actually did. So these are common problems, and there's ways to solve them, right? So the approach that we take and that we recommend that anybody should take if they're doing this is detectors as code. This has become a pretty popular uh, approach to these things, and I think there was another talk today that was talking about policies as code. So kind of the same thing. There's very well established and defined software engineering practices that really solve a lot of these same problems. And and our belief is that we should be applying these techniques and these ways of thinking to our detection engineering just as you do with software engineering. So uh, first and foremost, how do you track a requirement all the way to that implementation? So how do you know what's in your backlog of here's the things that we need to develop and we need to have these capabilities, and here's how we're moving along that practice. And then also from the other side of it, if you look at a rule within your detection platform, whether it's a SIM or an EDR or whatever, can you go back and say, what requirement was this actually solving? Like, why does this thing exist? And let me track it back. Who requested this and why and when, and so on. The second thing is having good coding and documentation standards. That way, whether I write a rule or one of my colleagues writes a rule, it all looks the same, and anybody else can come in and read it and kind of understand what's going on, and they know what to expect. So having that standardization is massively important. Having a way to control the source code, making sure that you have a repository that you can go back and look historically of every change that's ever been made to this and sort of see that life cycle. Unit testing, you know, when you write a rule, how do you know that it works before you just shove it into production and hope for the best? And then finally, how do you control that deployment process so you know that it gets deployed everywhere that it's supposed to? So ultimately, what's happened in the past is, click ops, right? Somebody will log into the platform, they'll make a change, they'll hit save, and there's no record of that happening. Nobody really knows that it happened, and you just hope that it doesn't destroy anything, and that's caused a lot of problems for a lot of security operations centers. So I want to talk a little bit about the way that we approach this. We run a managed detection and response service, so this is a big piece of our business, and we've learned a lot of lessons along the way because we've done things the wrong way and suffered the consequences. So we just want to talk through our approach of how do we go from an idea to a detection capability and get that into production in a safe way that's actually scalable. So I don't want to read all these bullets on this slide, but at a very high level, it's a four-step sort of continuous cycle. Somebody will come to us and say, "Hey, we've got an idea of something that we need to be able to detect," and that could be somebody from a threat intel perspective. That could be one of our pen testers who just came across this new technique, or maybe they're developing their own techniques. It could be somebody who just read a news article somewhere and just wants to know, do we have coverage for this, or could we have coverage? Anybody can do that, and that could also be a tuning request. So maybe you have a SOC analyst who says, "We've got a lot of false positives that keep hitting on the system, and we're getting way too many alerts. Can we tune this out or make some changes to this rule?" So somebody identifies a need, right? And then it moves over into our detection engineering team, where they will actually create the logic. They need to make sure that they're documenting it and putting it into the platform the way that it needs to be done. They're going to perform some testing, because we don't want to just write something and hope that it works, right? We're going to put it out there. We're going to test it and make sure that it's doing everything we think we're doing, and then we're going to deploy it and monitor and make sure that we keep an eye on that to make sure that it's continuing to do what we want it to do, and it's not just overwhelming our team. So that's a very, very high level overview. And so here's how we do it, right? So first and foremost, creating a new issue. We use Jira because, again, we're trying to approach this like software engineering. Jira, gets a lot of hate from a lot of folks, but ultimately it is pretty good from at doing the things that we want to do here. And we have a template that has to be filled out in order for anything to get done with this. So somebody can't just come in and say, OneNote, and then like leave a ticket there that makes no sense to anybody else. So we want to know why should this activity be detected? Put some labels on it, right? Is this Windows? Because we have folks who do Windows. Is it Linux? Is it some cloud platform? Is this an EDR tool? Whatever it may be. And then just links to reference material. So it's not, we're not trying to create a massive amount of work for folks, but there has to be some rigor in this. And I think that last piece is really important of having some sort of reference. We don't want somebody to just go post an idea somewhere. This needs to be validated in some point, and that can be a tweet, or it can be a Mastodon toot, I guess is what they call them, or it can be a blog post from some other organization, or it can be a white paper. But there needs to be something for our detection engineers to be able to look at and say, okay, what's the actual threat, and how do we actually want to be able to do this? So we learned, we used to have a ton more fields that we would have to fill out, and effectively what it did is nobody wanted to do it because it was too much work. So they would just not do that, right? So we learned that we really have to try to keep this simple, and what are the things that we actually need to have in order for this to be useful, and then just get rid of everything else. We also learned that we can't just do this for new ideas, right? We had to do this for tuning requests. So if you've got a rule that's firing too much and you want to make a change to it, any sort of change to our code, any sort of change to production has to have a ticket associated with it, and we'll walk through how that works later. And then we've also learned, and we'll go through this a little bit later, using smart commits. That way, if you look in our GitHub repository, you can link anything back to the ticket and who requested it and when, and things like that. So that's the first phase. We need to have an idea. This is where it starts, and somebody says, we need to detect this thing, and I need somebody to go figure out how to do that, and they'll pass it off. So the next phase is the detector development piece. So this is where we're going to put in the logic that says, if these things happen on a system, or if these things happen on a network, or if these log entries get created in this cloud environment, then we want to trigger an alert to our security operations team, right? So there's that detection logic piece, but we went a step further, and we said we need to create a template that captures more information, because ultimately, if an analyst gets an alert in the middle of the night and the person who wrote that rule is not around, they need to be able to know what to do with that without having to pick up the phone and call somebody, right? So we created a very simple template. It's all in YAML, and we just give it a name, right? Just a human readable name. Here's what's happening. A status, so it can be active, in testing, or it can be archived, and metadata. And this is where it's really important. So we want to tag it with the MITRE ATT&CK framework IDs that are associated with it. We want a plain English description of, if you see this fire, here's the things that you need to go look at, and here's the here's some maybe cases where this could be benign activity, and here's a surefire signs that this is malicious activity and it needs to be actioned, and here's some steps that you should be taking in order to investigate. Because if anybody from our most junior analyst to our most senior analyst needs to be able to get this alert, look at it, and know what to do with it in order for it to really be useful and in order for us to do our job. The actual detection logic, and then we also have built a capability to do unit testing. So we want to make sure that anything before any detector goes into our production environment, that we have ways to test and ensure that this thing is actually going to fire when it needs to, or if this is a tuning request, we want to make sure that it's going to stop firing in the way that we want to, while also still catching the things that we wanted to test. So if you're not familiar with unit testing in software engineering, if you develop a piece of code, you'll do some sort of unit testing, and basically what it does at a very oversimplified level, it says if I send this input to this function, this is what I expect back, right? And just do that over and over with a bunch of predefined data. And if it ever gives you something unexpected, then you know something broken, it's not working correctly. And we'll go through an example of what that actually looks like in practice. But ultimately, that's what we're trying to do, is we want to make sure that no matter what changes somebody makes, it can't get into production if it's not working the way it's supposed to. And we can't trust humans to do that accurately every time. So we automate that and make it part of the machine. So again, going through the testing phase, does it detect what you want it to detect? Does it not detect the things that you specifically want it to not detect? And is it resilient enough to withstand evasion tactics, right? If I just change the capitalization of this command, or I put it in quotes or something like that, does that completely break the ability for me to detect this logic? So we need to make sure that we're not writing what we call brittle rules that are just easily broken and bypassed. So some interesting lessons we've learned here for folks who have not done this before. We learned that we need to just have a generic false positive alert on every detection, because we have definitely written rules that will fire on every network connection or every new process. And when that happens in production, it causes all sorts of fun and exciting problems. So we've learned that anytime that we put something in there, we're just going to have a generic false positive. That way we know that it's not going to trigger on every possible event that comes across. And when we started doing this, we originally had a whole process that would spin up these networks, and it would go and automate these attack paths. And we would use that as part of our testing. And it was expensive, but it was also really cumbersome, and it took our team a long time to put new capabilities out there, because they would have to spend a day or a few days, designing this attack and then figuring out how to replicate it and spin it up. And then every time we push something new to production, we would have to test it, and it just got super cumbersome. So we had to really work with our team and our partners on the vendor side to really close those feedback loops and help our detection engineers know if their tools were working more quickly. And we'll talk a little bit about that here in a second. And then the final phase is the deployment of these rules. So once somebody has written a rule, they're pretty happy about it. We want to have a very controlled process of how does this go from a developer's workstation into the production environment. And for that, we use Git. So if anybody here is familiar with GitHub, or if you've ever done this in an enterprise environment, there's very simple things you can do of just being able to commit your code, to a repository, and it gets saved there, and you can see the entire version history of that code. But in an enterprise environment, there's a lot more things you can do that are very useful from a security perspective. So first and foremost, you can have and enforce verified commits. So we have this set up in our repo, where if somebody doesn't digitally sign their code, then it just doesn't go up there, right? So we want to make sure, worst case scenario, I do a lot of incident response work, and I'm always paranoid of what happens if somebody breaks into this account or into the system or whatever. So I'm always trying to think about ways that we can protect that. So you can make sure that you have to verify those commits. Smart commits is a feature within GitHub and Jira where you can actually link the two. So you can see any version history of your code. You can link it back to that ticket we talked about earlier, and then you can say, okay, well, this piece of code was written to address this requirement, and be able to map it back and forth. And it's useful for troubleshooting, but frankly, it's mostly useful for auditors. So if anybody's gone through a SOC 2 type of assessment, auditors want to see tickets for everything and have this evidence. And it makes that a breeze, and auditors think that it's the greatest thing ever. So that's super useful. Again, our unit testing. So we want our developers to test things on their systems before they deploy anything. But before it actually gets into production, we want to be able to automate that, and it's just not allowed to go into production if it doesn't pass all those tests right here. And then we have code review. So we can say this can't go into production unless 2 or 3 other people review it and give it the okay, right? So no one person can go and make changes to our environment. There's got to be a multi-person verification that this is a good idea. And then the automated deployment. So once all those things happen and once all those boxes are checked, then it just goes, right? And you don't have to go through and click around in the interface several times. So that's kind of what it looks like. I was going to do a demo, and then we realized that I wasn't going to be doing this off my laptop, so I recorded a video, and I think this is going to work. But I'm going to ask AV folks here to play it, and I'll just kind of talk through it. But I wanted to show an example of what does this look like from start to finish. So I chose an example of a very current attack, and if you can just pause it here. So OneNote has become a very popular threat vector here recently. Threat actors have realized that Microsoft put all these controls in place to prevent people from emailing Excel documents or Microsoft Word documents and using them for malicious behavior. Nobody did anything with OneNote. Some bad guys realized that, and they said, hey, we should totally use this to send phishing emails, and they've started doing it. So this is from a while ago, but we recreated this. So it starts by creating our ticket, right? So we've got this Jira ticket that says we need to catch OneNote spawning shells, which is one of several ways that threat actors can abuse this. And you'll see here that I put in a quick description of what we're actually trying to catch, and then some references at the bottom. So there's one from Proofpoint, one from 4Core that talks about how these attacks work. So you can go ahead and start playing again. And then as I do that, I'm a detection engineer, so I'm going to mark this as in progress, and I'm going to create a new branch in our GitHub repo. So again, this allows us to make some changes to the code and then be able to merge them in later. So this is VS Code, and I'm going to create this new branch, and now I'm going to go start making changes to the actual code. I know that this particular rule right now, it has a bunch of logic in it to detect shells spawning out of Microsoft processes, but we want to add OneNote. But before I do that, I'm going to test it once. So I'm going to fire up OneNote in our detection station, and I'm trying to figure out how can I create a malicious attachment without having to go and download actual malware. And again, this is a very compressed version of this, but the easiest way I figured was just to put my own malicious link inside of the document. So I'm going to create a shortcut to the command prompt on my desktop. I'm going to look at the properties here, and what you can do with link files. And I'll just let this go, and then we'll go ahead and can we go ahead and pause it here? So if you create a link file on Windows, this is a fairly common tactic these days. You can just create a link file to the command prompt and then tell the command prompt to do whatever you want to, and it looks normal to a user, right? So they click on it, it's going to do this thing. So I modified the shortcut to just run the command do evil and eat sandwiches, and that doesn't actually do anything, but it's a close enough approximation to what an actual attack looks like. So you can go ahead and play. So I'm going to make these changes to the thing, and I decided I was going to change it to ampersand here because that's better, formatting for Windows commands, even though it's not a valid command. But anyway, I'm just going to drag that into my OneNote, and I'm going to click it because I'm a user who got this, and I was told to click it, so I click it and I open it. Right now, I've got an EDR sensor on this, and I'm going to move over to another window, and we use a tool called Lima Charlie as one of our EDR vendors. So if you pause it here, so right here, what you're looking at is our dev environment, and the system that I created this test attack on has an EDR agent running on it that's collecting all this telemetry. So when I clicked on that, you'll see here on the right, there's some JSON, and it's kind of hard to read, but basically this says that the command cmd.exe/c do evil and eat sandwiches was run from the Microsoft OneNote command. So Microsoft OneNote is a parent, and that command prompt is the child. And that's what we're going to look for here. So another big piece of how we think about detection engineering is we want to look for these weird patterns of behavior that should never happen in order for us to find bad things. So I don't care what's in that OneNote document. I don't know. I'm not going to write an antivirus rule to catch every possible version of this. But I know that if somebody puts a malicious link inside of a OneNote document and a user falls for it and clicks on it, it's going to cause a command shell to spawn. And it's not perfect because it could also be PowerShell or MSHTA, or there's a handful of other vectors. Um, but in this example, this is what we're looking for. We really want to just know if one note causes this general process to spawn, how will we catch it? And we can see an example of it right here that we can use for testing. So go ahead and start playing again. So what I'm going to do here is I'm just going to copy this event, and this goes into our unit testing capability here. And I'm going to go back to my VS Code window where the actual logic is stored. And this is an existing rule, and it's checking for all these different Office documents to do it. But I'm going to create a unit test here at the bottom, and I'm going to say this is one note spawning a shell. And the Lima Charlie EDR tool has a really great feature that allows us to replay a series of events in order to determine if a rule is going to fire. So I just paste that raw event there, and I say this should fire, and hit yes. And what we've written, oh wait, now I've got to go up and actually modify the rule, right? So I'm going to intentionally do this incorrectly, and I'm going to put some logic in here that says for any new process that's Windows, we're looking for all these different versions of Microsoft documents, but I'm going to put it in the wrong place in the rule that's going to cause it to break everything, right? Because I want to demonstrate what happens when things go wrong. So I'm going to save that. I'm really proud of myself. I changed Outlook to OneNote. My job's done. And I'm going to run my unit test here. And we created a VS Code plugin to automate all of this. And you see here at the bottom, it says we're running the verifiers for this test. And you can see that the verifier failed because now our logic is completely broken and it doesn't do anything. So ultimately, and you see every use case failed. So if you can pause it there, what I did here, and the way this rule is supposed to work, it's supposed to say if you see any one of these Microsoft Office types of processes that are running with a child process of PowerShell or command prompt or whatever it may be, then fire an alert. But what I did when I changed this logic, when I was acting like a sloppy detection engineer, is I just pasted this new thing in here that actually changes the rule to say if a Microsoft Office document spawns another Microsoft Office document, or and then it spawns a shell, right? And that's really not what we're looking for. So I made a mistake, but this unit testing framework caught this mistake and stopped me from pushing this out and breaking our ability to detect all this. So now I'll go through and I'll change it. You can hit play again. I'll change the logic to do what we actually meant for it to do, which really is just putting it in the right place within this rule. And we'll tab that over because YAML cares about tabs. And now I'm going to run the verifier test again. And now it's going to go through this, and you see that it tells me everything actually worked. All my verifiers passed, and now I can commit this to our source code repo. So now I know that this is actually detecting the things that I want it to detect, and it's not breaking any of the old rules that we had in place before, right? So again, here's an example. If I was editing this rule and I just went and like broke something, like I accidentally deleted a random character somewhere because I was not paying attention and my cat like jumped on my keyboard or something, then I can see now, again, the verifiers fail and I have to go back and fix it before it passes again. So it's a really powerful capability. Too many people will just go and put new rules into production with no testing, and it really causes issues that sometimes you just never even notice until a breach happens and you realize that this thing was broken the whole time. So here I'm going to go and, if you're familiar with Git, I'm going to go and commit the change that I made. That way it will go into our source code repo and it can be reviewed by other members of our team. And because I'm wanting to track all this, I make sure that I put the ticket number that's associated with this change within my Git comment. So that basically allows anybody who's going back and looking at this and saying, why did Paul make this change? They can go back and say, oh, this is from ticket DET-301, and they can just go search for that and see the whole process, right? Put a note in there, and then I made it too long, so I had to find a way to make it shorter. And then this will commit, and then we'll pop over to our GitHub instance to take a look at that as well. So if I go to GitHub, I see that now there's this new branch, and I'm going to create a pull request. And I'm going to leave a note here, and I'm going to request a Tommy G from our team, take a look at that and review it. I'm going to assign it to myself and put some labels. And really, this is at this point, it's saying, hey, can somebody else on the team go back and check my work and make sure that this is valid and I didn't do something stupid before we push into this? Or do you have a better way of doing it, or is there a more efficient process? And this will create a pull request. It's going to send an email to our team, and it's not going to let me do anything here because it tells me that this review is required, and I'm not allowed to do anything else until somebody else gives me the thumbs up, right? So you don't want to have one person who can go through and modify that. So that's really it. When Tom gets this email, he'll pop into the into the code, take a look at it, and he'll see the changes that I've made, and then he can either give me the thumbs up, thumbs down, and then these unit tests, again, we hope that everybody runs them themselves and that they're doing their job, but before it can actually go through and make the change, GitHub is going to verify for me that that it actually passed those tests. So if we can go back to the slide, so I think I just got one more, and my time is almost up. So this is putting it all together. This is the process that we have in place, and everybody doesn't have to do this, right? We're not saying that this is the only way to do it, but I think that some of the core tenets here are massively important. If you're going to be running a security operations team, and you want to have custom detection capabilities for your organization, having something like this that can help standardize and control how you're putting code into your production environment and make sure that you're controlling how you're creating these new capabilities, it really allows you to scale. If we didn't do this, then we would have no idea, when a customer asks us, hey, can you detect this new OneNote thing? We would have to just kind of ask around, like, did anybody write a rule for that? Or let me go scroll through all our rules and see if anybody did it. Whereas this allows us to just go through and say, hey, let's go just search our tickets. And yes, it looks like we put this in place and we developed this capability, and we've had it in place since January 15th, which is when I'm just making up these dates, but since January 15th, when these attacks first started occurring, we created this capability. Or in an ideal situation, we can say, oh, well, we actually have had a rule for this since 2018 because we anticipated that it could potentially be abused then. So we were ahead of the curve. But having this process, instead of just smart people doing smart things and hoping that everybody's doing it roughly the same way, it really adds a lot of control, a lot of and a lot of assurity, right? If you're a leader in an organization, you want to know that there is some process that's happening and that you can actually verify what your people are telling you, and you're not just hoping that they're getting it right every time. So that's it. Any questions?
Hey, quick question about, so I've noticed a lot of detection engineering relies on YAML-based structures instead of like other structures like JSON. From your experience working with YAML, is there any particular advantages YAML has over JSON, or is it just syntactically preferred?
Yeah, I have a deep hatred for YAML. I don't know why. That's YAML and JSON are kind of the same thing. It's just a different sort of formatting, but there's all sorts of converters that will convert from one to the other. I don't know of any specific reason why that became the language of choice for any sort of detection engineering, but it just is. So I don't have a good answer besides I don't like it.
Yeah, I also hate YAML.
Yeah. I don't like anything that relies on like spacing for syntax because it causes issues like what we just saw right there.
One quick follow-up question. You mentioned before that you did unit testing with containerization. How does the previous process differ from the GitHub Actions? Because isn't GitHub Actions also containerized?
Yeah, it is. What we had to do though, because GitHub Actions is good for very short-lived sort of processing steps, and what we would have to do sometimes is also, and I think GitHub Actions you can only use like Linux-based containers to run scripts in a handful of languages. So what we would have to do before is if we wanted to test some detection capability on Windows, we would have to spin up like a Windows VM with a bunch of I can't remember the name of the tool right now, but a bunch of scripts that would kind of initialize it and get it set up and then run the attack and then make sure that we called it in order to do that. So Lima Charlie, the tool that we use there has an amazing replay API that just says if you capture these events and just put the JSON and into a list of events here, and then we can run the logic against those events, and it's just a quick like REST API call in order to trigger that. So we found that's been massively helpful, and it took our deployment time. It used to be when we would deploy a new rule, it would take us like 3 hours to get through all the unit tests because we had to do all this this work, and now it takes about 45 seconds to a minute to deploy it across all our organizations, which is massively helpful, especially when something's broken and you need a fix right now. There's nothing worse than just like sitting there waiting on the wheel to spin for 3 hours. So, but anyway, that's the reason why we couldn't use GitHub Actions, is because we were doing stuff with all the different operating systems, and we would have to like come up with hacky ways to test it. And also we were using Jenkins at the time, which I'm very happy that that's not the case anymore.
Absolutely, thank you.
Yep. All right. Yes. Lunchtime. Thank you, everybody.